Hello everyone, this is the fourth video of the Fluid Simulator series. In this I will explain the settings of the Particle Advector and the settings of these nodes and how to use them. In my previous video I have explained the settings of this main Fluid Simulator node. Now let's focus on this Particle Advector. So if you want to move the particles based on the fluid motion, you can do that with this Particle Advector node. See how these particles are moving with the fluid. Let us use the grid. Okay. You can disable or enable the particles from this switch node. And this is the main Particle Advector node. To advect the particles based on the fluid motion, first you have to input the fluid geometry from this Fluid Simulator node to this. And second, you have to also input the points that you want to advect based on the fluid motion. I have distributed the point on the fluid geometry and then using those points for the advection. And this node has a similar setting pattern. You have initial setting and dynamic setting. As we have in the Fluid Simulator node, we have initial setting and dynamic setting. So in the initial setting, you can basically enable the projection of the particles onto the fluid geometry. You can wrap the particles and you can set the initial color. If I disable this project the particles onto the fluid geometry, you will see that the particle will move out from this geometry. See, they are moving away from this grid. To keep them onto the grid, you have to basically enable this option, project the particles onto the fluid geometry. Next is the wrap option, which is similar to the wrap condition we have in the fluid. Basically, to move the particles which are on this edge to the bottom edge or on to the right edge to the left edge and vice versa. And this is the initial color. Let me disable this one, and if I set the initial color, let's say orange, and refresh the simulation, you can see particles have this color. We can maybe make them red. See, you can set any colors using this option. I am using the color from the grid, okay, this fluid grid. Next we have the dynamic settings. We have internal dynamic setting and the external dynamic setting. So in the internal we have this damp factor. Basically we can damp the motion of the particles with this factor. So let me disable this fluid grid so that you can easily see the particles. Now if I run the simulation, so this is the motion of the particle without damp factor. If I make this 0.75, you will see that the particle are moving less. Particle motion get damped. And if you make this one, then particle will not move. See, they only are having collision force, but they are not moving with the fluid. Next we have external dynamic settings, color, collision and particle collision. Okay, let's use this color. So to use this, first you have to enable this color option, and you can also provide the color selection for the particles. By default it is true for all the particles. These are the modes for the color update. You can mix the color, change the color value, hue or saturation. And this is the factor to control the effect of this newly added color. You can add this color from the fluid geometry, or you can use the color from external object, like we are using the color for fluid from this object. So if I run the animation, you can see we are updating the color of the particle from the underlying fluid geometry. After that we have this collision option and particle collision. Let's first disable them and see the motion of these particles. Let me hide this grid. Let me also make this damp factor 0. See the particle moving, but they also going through this collider object, this cube object. So to make this particle collision with this geometry, you have to basically first add this geometry to this socket and then enable this option. Then it's going to collide with this external geometry. See, this object is pushing away the particles. This is really nice feature. Can use this in case where there is leaves on a water surface, and when boat pass through these leaves, it should push away those leaves. In that kind of scene, you can use this option. And second is the particle collision. Right now some of the particles are overlapping, but we can make the particle collision with this option. If we enable this, you can see that all these particles are moving away from each other so that they don't overlap each other. See, and here increase the number of iterations. Higher the number of iterations, make sure that the particle should not overlap. You can also increase the strength of the force to push the particle, and you can also change the distance of this effective force. The force is effective within this distance from the particle. You can use the radius of the particles as this distance. Now if I increase this force to let's say 0.5, it's going to really strongly push these particles. So these are the settings for the particle advector. Now I'll explain the velocity setter nodes and the forces nodes. So let me disable these particles and we're going to use only this fluid grid. So you have these 2 velocity setter nodes and 7 forces nodes. Okay, first I'm going to explain these nodes. Let's focus on this fluid velocity from collider. So if I expand this, this is the fluid velocity from collider node. This node gets the velocity from this collider, and then we can use this velocity to reset the velocity of underlying grid points. So if I run this, see, this object is adding the velocity to the fluid. This node has few settings. You can change the scale of the velocity, and here you have to input the object or the geometry. So you can use the mesh object or you can use the curve object. And if you use the curve object, you can change the length step for sampling from this option, and this is the time step to calculate the velocity. So velocity can be negative or positive. So if I set this 1 or positive, the object going to push the fluid with it. Okay, or you can say it has the forward object velocity. If I set it to -1 or less than 0, it's going to push backward fluid in the velocity direction of the object. Object is moving in this direction, but fluid is pushed back in this direction. So it output the velocity and also output the geometry that you can use with the Falloff node to further control the effect. By the way, these Falloff nodes are freely available on my Gumroad page. You can download from the link in the video description. Let's use a curve object. Let me add this here. So if I select this circle and let me enable this object properties. So if I refresh this, yeah, everything is changed into red because we have to change this to a spline because we are using a curve object, not the mesh object. So we're going to use a spline edge Falloff node. Let's connect this to this and make this to 0, 5. Now if I rerun the simulation, see, we are only updating the color to this. Now there is no velocity because this object is not moving. Let's make this a positive velocity. So if I move this object, see, we are adding the velocity to this fluid based on this curve object. We can even add the velocity based on the rotation of this object. If I rotate this object around the z-axis, see, it going to push the fluid accordingly. See, or you can even rotate around any other axis, like let's say rotate on the x-axis. Or maybe something like this. This is how you can basically update the velocity of the fluid based on the object. And now I'm going to explain this node. This is the velocity from the noise. Let's put this here. I'm going to change back to this cube and I'm going to delete this circle. Let's also add this to this. Now this node is basically provide the velocity based on the noise. You can control the velocity scale, and you can also choose a custom noise if you need. By default it has these noise settings: seed, then you have this noise speed and noise scale. Okay, so if I plug this into this velocity socket, then we're going to add the velocity near to this object. Okay, because we are using this Falloff which is based on this cube. So if I run the simulation, see, we are adding this noise based velocity to the fluid. You can even combine these velocities together to create a certain kind of effect. So let's add them together and then make this velocity in the negative or in the backward direction. And I'm also going to increase this vector around maybe 0.75. I think we have to increase the noise scale, maybe a 3. Yeah, we have this, see, we have this noise pattern, and also this fluid is moving in the backward direction. This is how you can basically add the variation to the fluid motion using these velocity setter nodes. We have these 7 forces nodes: curve radial force, curve tangent force, central force, collision force, curl gradient like force, gravity force, and the turbulence force. Now first I'll explain the turbulence force, which is already connected here. To use this, first you have to enable this option, enable force. Then it's going to add the force to the fluid. Let's also disable the velocity from this object and the color. See, this turbulent motion of the fluid, this is based on this turbulence force. So it has the strength to control the force. Then you can basically add a custom noise if you need, or you can use this these default noise. You can change the seed, speed, and scale. Next we have this gravitational force. Let me disable this. If I add this to the force, and by the way, by default it is in the negative z direction, but this grid is in the xy plane, so we can make this in the negative y direction. You can see that this fluid is moving in the negative y direction. You can also combine these forces together. Just add the add vector node, then add these forces together, then input to this socket. Now we have this gravity as well as we're going to have this turbulence. Let me increase this gravity around 0.05. See, it's moving downward, and also we have this turbulent motion. You can mix these forces together based on these Falloff nodes to create a really nice pattern with these forces. So move on to next force, that is the curl gradient force. This force is basically generate a spiral like pattern in the fluid. Let me delete this, and if I add this here and run the simulation, you can see that we have a spiral pattern. Oh, I think its scale is quite large. Let me make this 2. See, we have these kind of motion in the fluid. So here you can basically choose between the curl or gradient. You can switch the direction, means make these spirals clockwise or anti-clockwise, and then you can basically add the custom noise if you need for this color gradient, and these are the default settings for the this inbuilt noise. So let me show you this direction quickly. So right now this spiral is moving in this direction, or this anti-clockwise direction. If I make this switch enable, you can see that this spiral is moving in the clockwise direction. Okay, same if you change a curl to gradient, you're going to have a different kind of pattern based on the gradient of the field. Next we have this collision force. So let's bring this here. So let's connect this to the force socket. So in this node, you have to provide the object. That can be a mesh object or a curve object. And if you use curve object, you can change the length step here. And this is the distance and falloff setting for that particular object. And you can also enable the collision inside the volume of the object. However, you can also enable this option for the curve object, but make sure that the curve is perfectly aligned with this grid. Let me add the curve. So that curve is something like should align with this grid. It should not be like this. Okay. So if we add this curve to this node and run the simulation, let me enable this color option from this collider and also the velocity, so that we can see the motion outside this circle. See, fluid is only moving outside this circle. It is not moving inside this circle. However, if you get some motion inside this circle, you can basically further suppress that using this mask option. Let me show you that. So this is basically the mask, and you can use this mask option as a damp factor to damp the motion of the fluid inside this circle. See, now there is no motion inside this circle. So let's check this for a mesh object. Let's add maybe icosphere. Let me delete this circle. Now we have this icosphere. So let's rerun this simulation. Maybe slightly increase the scale of this. And also I'm going to change this to a wireframe so that you can see the motion of the fluid. See, the fluid is colliding with this object. We can also put this something like here where the fluid motion is high. So if I rerun the simulation, see, fluid is going in this direction or also going something like this. It is not going inside this, in this icosphere. Okay, you can change the distance and falloff according to your project. You can define the distance from this object up to which the fluid don't move. Okay. Next we have this central force. So this is the central force. It can be a linear or based on gravitational. Gravitational is 1 by r square. Central means proportional to r or the distance. Okay, so here you can use the mesh object or curve object. So these are the modes. You can use the object location, object mesh, curve, geometry, or a particular location. Okay, and if you use the curve object, you can change the length step. So let's use this icosphere. We're going to use this as mesh. So let's move this icosphere here. Let me disable these settings so that we can see the motion from this force. See, this fluid is moving away from this icosphere. Let me make this 0.05 or really strong. See, you can even make this attractive by making this strength negative. It's going to push the fluid toward this icosphere. Okay, you can also make this gravitational 1 by distance square. See, everything is pushed toward the surface of the psychosphere. We can move this to this side. Next, we have these forces based on the curve radial force and curve tangent force. Let's duplicate them. First, we're going to focus on this curve radial force. So for this, you have to input the curve, and then you can change it. Is basically sampling step. This is the distance and fall off from that particular curve. So if we add this curve, so let's select this curve in this node. See, fluid is moving away from this curve. Let me make this. See, it's moving away from this curve. You can also make this attractive. Then this curve going to pull the fluid toward it. Okay. Next, we have this curve tangent force. Let me select this base here, a circle. If I connect this to the force, and if we rerun the simulation, see, it is moving the fluid along the tangent direction of the curve. You can even make this negative, then it's going to move the fluid in the opposite direction. You can even make this strong. Okay, these are the forces node, and they are same for both the fluid simulators. You can use them for both the fluid simulators to get a different kind of pattern based on the forces for your particular project. This is it. In the next video, we're going to do a particular example with these fluid simulators. See you in the next video. Happy noding. Bye.